Good morning. The problem, using common bases. So, for example, I could write 25 as 5 to what exponent? 2. Yeah, right. 25 is 5 squared. So I have 5 to the x equals 5 squared. And so now that since our bases are the same, we know our exponents must be the same. So we could say that x equals what number? 2, good. All right. That one's a little bit straightforward. You probably knew the answer before we wrote anything down. You said 5 to some exponent is 25, and you knew it was 2. But you can use this idea to do things that are a little bit more complicated. So let's look at number 2. Should we rewrite the 2 or should we rewrite the 16? The 2. So I could make 2 16 to what power? That actually seems hard. It's possible, but how about if we try rewriting the 16? 16 could be 2 to what power? I heard 2 votes for 4. You want to try it out and see if it works? 2 times 2 is 4, times 2 is 8, times 2 is 16. It worked, right? So 16 equals 2 to the 4th. So we're going to replace 16 with 2 to the 4th, keep everything else the same. All right, now, I have a power to a power. I have 2 raised to the 4th raised to the x plus 2. Does anybody remember, what do we do when we have a power to a power? What do we do with those 2 exponents? Multiply them, thank you. So we're going to multiply the 4 times the x plus 2. So I have 2 to the 3x equals 2. And then I'm going to multiply the 4 times the x and the 4 times the 2. So I get 4x plus what? 8, good. All right, so now I've got both of these are base 2, and you've got different exponents, but we know that since these 2 expressions equal each other, those exponents must equal each other. So I can write that 3x must equal 4x plus 8. And take a moment and solve that. Some of these problems that seem like they're almost done have become tricky for some of you. And I think that's just because of the algebra 1 that you learned online. So take a minute and solve that for x, and then we'll regroup. One method that works is to subtract the 3x and subtract the 8. So subtracting the 3x would give you 1x on this side, and it would give you a negative 8 on this side. But what I'm seeing a little bit more of is subtracting the 4x. They both work. To get a negative 1x. And then this cancels. And then dividing by negative 1. And we get x equals negative 8. What questions do you have? So that was one method. If your method also got you x equals negative 8, it's probably a good method. It's not the only way to do things. Okay. All right, number 3. Some of you have already started thinking about number 3. In number 3, I'm going to suggest that we might want to change the base on both sides, because it's kind of hard to write things as powers of 64, and it's kind of hard to write things as powers of 1/4. So we could change both sides to be powers of 4. Let me suggest that for you, and I want you to take a minute and see if you can write both bases as powers of 4. Sorry, I forgot to record that. I'm going to say it one more time for the recording. We replace 1/4 with 4 to the negative 1. We replace 64 with 4 to the 3. We had a power to a power, so we multiplied our exponents. And now that the bases are the same, we can say that the exponents are also the same. So we can write negative x plus 3 equals 3x plus 6. Okay, take a moment and solve that equation. You could have subtracted the 3x, or you could have added the x, or maybe you decided to subtract the 3 or the 6 first. Doesn't really matter what order you're doing it in. Just make sure your steps are legit. I'm going to add x on both sides. If you didn't do it that way, just make sure my steps make sense to you and we get the same answer. So I get 3 equals 4x plus 6. I haven't gotten that far yet, but maybe. And now I'm going to subtract the 6. So I get negative 3 equals 4x. And now I'm dividing by 4. So I'm getting a fraction, which could be a decimal, right? So I get x equals negative 3/4, which would be negative 0.75. Is that what you got?
Yeah.
Go. Okay, so wish I had a different color, but I don't. Okay, so isolate the base and then rewrite as a log. Oh, you guys remind me to return quizzes today. In general, the quizzes were good. All right, so isolate the base. What number is the base of an exponential here? Is it 8, 10, or 35? 10, yeah. So we've got to get this 10 to the 5x plus 4 by itself. So I got to get rid of the 8. What do I do to get rid of the 8? Subtract, very good. So let's subtract the 8. All right, so now to solve this problem, we're going to rewrite it as a logarithm. So what would be the base of the log? The base of the log is the base of the exponential, which is? 10. Good. Yeah. Yeah. So Sky points out that when it's log base 10, you can just write the word log. And I encourage you, if that statement made sense to you, to just write log. It's good practice. I'm also going to write log 10 on my paper because I know some people are still not processing that, and I don't want to be confusing if that's where you are. So I'm going to write log base 10, but if you know that log base 10 is written as just log, go ahead and do that, okay? All right, so it's going to be log base 10, which is just log, of 27 equals 5x plus 4, and all of a sudden we need Desmos. So please open up Desmos on a computer. And again, so right here I have log 27. Remember, log by itself means log base 10. It gives me exactly the same answer as if I wrote log base 10 27. We're going to round to 3 decimal places because that's what we're going to do in our project. So we're going to just practice the 3 decimal places right now. So I'm going to substitute 1.431 for my log base 10. All right, now I have to solve for x. I have to get rid of a times 5 and a plus 4. What do I get rid of first? The plus 4, that's right. So if you're not sure, when we're undoing operations, we use PEMDAS opposite. When you do operations, you use PEMDAS, that's your order of operations. When you're undoing operations, you use it opposite. So you start by undoing addition and subtraction. So we're going to get rid of the plus 4 with a minus 4 on both sides. Minus 4, minus 4. And you can use your Desmos again on that if you want. I get negative 2.5 0.569 equals 5x. All right, and then how do we undo 5 times x? Divide, good. So I'm getting an answer. You guys tell me if you get the same answer as me. Negative 0.514. Did you get the same? Sally got the same. Sky got the same. Owen got the same. Good. Okay. All right, so I have 4 times e to the 2x plus 2. What do we undo first? The times or the plus? The plus 2, right. So we're going to subtract the 2 first. I have 4e to the 2x equals 14. All right, and then how do I get rid of the 4? Shelly says divide. Anybody want to agree? Yeah, good. Okay. So I have e to the 2x equals, what's that, 3.5? Yeah. Okay. All right. So now our strategy says to rewrite this as a logarithm. What would be the base of the logarithm? Who said that? Good job. But the base of the logarithm is e. And log base e has a special name. What do we call it? Natural log. Good. The natural log is log base e, and we write ln. Okay? You could literally write log base e in Desmos, and Desmos would do all the right work for you. But if you're looking at a textbook, it's always going to say ln, so I want you to understand that ln is log base e. Okay? I'm going to actually write it both ways for you. So first I'm going to write log base e of 3.5 equals 2x. And then I'm going to remember log base e is ln, and that's 3.5 equals 2x. Okay, and now I'm going to put ln 3.5 into the calculator, and you should do that as well. I'm kind of curious if I type ln if it works. I think it's going to. No, I don't think it's happy. Oh, it does work? Awesome. Thank you. All right. So ln 3.5, I get 1.253. Does that look right? Okay. 1.253 equals 2x. And then to get the x by itself, what do I do? Divide it. Good. All right. 1.253 divided by 2. So I have 0.627. All right, so we're looking at the YouTube video, and the views on this video are growing exponentially. Interestingly, in a natural log kind of way. But anyway, this is the equation that's describing that exponential growth. And we want to know when the views will reach 2,500. So the y is your ending amount. So we're going to put the 2,500 for your ending amount. Okay, and we're trying to get e to the 0.2t by itself. So how do we get rid of the 80? Divide it. Yep, good. So we're going to divide by 80. And I'm going to use Desmos to do that. I get 31.25, which I think I saw on some of your papers, so I know I'm in the right direction here. All right, and now I'm going to rewrite this as a logarithm, and it will be log base what? What's the base of your exponential? Yeah, so it's going to be log base e. Now, I saw some people write ln, and I saw some people write log base e, and they do both work, okay? I'm writing it both ways for you because I know it's just a jump for some of you. Log base e of 31.25 equals 0.2t. And log base e is exactly the definition of natural log ln. Now you can actually type into your calculator log base e of 31.25 or ln 31.25. They should give you the same thing. I'm going to do the second one because it's just a little shorter. And I get 3.442. And then I'm going to divide by 0.02. Dividing by 0.02, will that make your answer larger or smaller? Bigger. Yeah. And I said the number wrong, didn't I? I said 0.02. It's 0.2. But both of them would make your number bigger. What did I find out? 17.21 what? Days. Yeah, days until you have those views. So remember in rounding to think about if your answer is legit. In this case, you could have 0.21 days because it might not happen like right at midnight. It might happen 0.21 throughout the day. Let's take a look at this first one. I saw a lot of people get the first step right where you added 2. And then you rewrote it as a logarithm. And I just wanted to show you this little trick. You could actually put into your calculator log base 422 minus 4 to get that all in one step. And I want to show you something else that Sky found for us so we don't have to go into functions all the time. So if you want to do a log base 4, instead of having to go into functions to get that base, Sky says we can do underscore, which is like shift and dash, and it brings us down there. We can put in the 4. So that's like a bit of a time saver. It's nice. Log base 4 of 22, and then minus 4, like that. Oh, that looks like that's going to round. No, that rounds right. That's negative 1.770 is what I'm getting. All right, does anybody want to hear that trick again for doing log base 4? Okay, so normally we were going into functions to get it, but you can also do log base 4 by typing log and then doing underscore. That's shift and dash, and that will give you the base space down there, okay? All right, way if you want. So it's a log base e of 10 equals 3x minus 1. Log base e is ln. ln of 10 equals 3x minus 1. So I'm going to type in the ln 10. .303. Okay, what do I do next to get x by itself? Say again? Add 1. Perfect. Add 1. 3.303 equals 3x. I think I can divide that in my head. Let's see. 1, right? 0.101. Is that right? No? Huh. Okay. I'm just going to try it because sometimes my instinct is off. Yeah. Okay. All right. We're going to do just a 3-minute break because it's a short class today. Okay. So 3-minute break and then we'll be back. All right. So just for the purpose of the recording, I'm going quickly through this one. It's about an investment whose value is rising at 5% per year. The initial value is 20,000 and we want to find the time until it reaches 35,000. So I put 35,000 for the end amount and then the equation already gave me the rest of this. Dividing by 20,000 and then rewriting as log base 105 of 7/4. And that gives me my time of 11.47 years. So problems that we solved before just to find the end amount of money, now we're able to solve them for the time. And you'll do that in your project as well. All right, so we're going to go back to some new problems. These are problems where the equations have logarithms in them. Okay. So when we're solving logarithms on one side and logarithms on both sides, we do have to know that logarithms have restricted domains. Remember that like a logarithm has a vertical asymptote like this, right? And it goes like this. So every logarithm has a restricted domain. So there are some numbers that x cannot be. So once we solve these equations, we're going to go back and check and make sure that the x values are allowed. So x's cannot be, the input for the logarithm here cannot be 0 and it cannot be a negative number. And let's see, so you can't do the log of 0 and you can't do the log of a negative. So just write, remember to check answers. You can't do a logarithm of 0 or a logarithm of a negative number. Okay? And that's going to mostly happen with the problems that have logarithms on both sides, but we'll check these for good practice anyway. So to solve this logarithm, we're going to rewrite it as an exponential equation. What's the base of the exponential going to be? The question was, what's the base of the exponential? And Sally suggests 4. What do you guys think? Okay. So it's going to be 4 to the 2 equals x plus 3. Oops, you can't see the 4. There's the 4. 4 to the 2 equals x plus 3. 4 squared is 4 times 4, 16. And to get x by itself, I have to subtract the 3. So let's just check and make sure that we're doing the logarithm of a positive number, and then we're good. I get x equals 13. So if I put 13 back in the parentheses, 13 plus 3 is 16, and that's allowed. So my answer is good. Okay. ln means log base what? E, good. So I'm just going to write on top of my ln log base e because that's going to help me write that as an exponential. So it's going to be e to what exponent? To the 4, good. All right, e to the 4 is something I can't do in my head, so I'm going to use Desmos. You should too. Get 54.598. And then to get x by itself, what do I do? Add 3. $57.598 equals x. Is this number allowed? Yeah, you got to put it up here and check. So I would subtract 3 from it and I get 54.598, which is still a positive number, so I'm good. All right. When you have a logarithm on both sides, if you were like algebraically trying to get rid of it, the process could be called exponentiate, which is fun to say. Exponentiate. But you don't have to actually show that step. I'm going to show you it so you know what it looks like, but it's okay if you just skip over that step. I just want you to know that you're not dividing by log base 4, because when I have log base 4 of 8x plus 17, I'm not multiplying two things together. Logarithm is a totally different function. And what is the inverse of a logarithm? Exponential. So the inverse of a logarithm is an exponential. So to get rid of a logarithm, we use the same base, and we do this process called exponentiate. Now, that is literally what cancels out these log base 4s. Okay. Now, that's okay with me if you don't write that step out. If you go straight to 8x plus 17 equals x plus 3. But if you divide both sides by log base 4 to cancel them out, not only will I cry, but also you will lose a point. Okay? So do not divide by log base 4. That's not a legit step. The step is literally called exponentiating both sides, but you can also just go straight to this step.
You just solve it.
Yeah, so now we just solve it. Okay, so what should we do? Do you guys want to subtract 8x or x? I'm gonna go with Gideon's suggestion because it seems like a easier thing to do. But you could subtract 8x. What's 8x minus 1x? 7x. Good. So I have 7x plus 17 equals 3. And then how do I get rid of the 7? Divide. Good. What kind of 2 do I get? I'm getting a negative 2. All right. We got to check this, though, because negative 2 itself is a negative number. We have to see, does it make the parentheses negative? So I'm going to have everybody from Carmen towards the door. You guys are going to be checking 8x plus 17. Put in that negative 2. And then everybody from Gideon over to the window, you are going to be checking x plus 3. Substitute the negative 2. See what you got. No, Ben. You can do the first one. All right, Izzy, what are you getting? Anybody else getting 1 on that side? Okay. How about on this side? What'd you guys get? 1. So 1 is positive, right? So it's okay. So it's okay that we got a negative answer because when we substituted in, this part in the parentheses turns positive. So we're good. Okay. All right, let's do the next one. What is the base of log? 10. So if you do the exponentiate step, it's going to be with a 10. Okay. Yes. Yeah. So what's 8 times negative 2? Oh, you're telling me the answer to log base 4 of 1 is 0. That's I just need to know the number that's inside the parentheses. So that number was 1. Does that make sense? Yeah. So it's okay if the answer to the whole thing is 0. That was a good question. All right. You could subtract the 4x or add the 3x. What do you guys want to go with? Hi. Add the 3x. Good. Thanks, Miss Bruins. All right. Should I get rid of the 7 next or the negative 9? The negative 9. (14 equals 7x), and then divide by 7, right? So we're getting x equals 2, okay? All right, so from Carmen over to the door, check the first one, and then from Gideon over to the window, check the second one. Let's see if we get a positive or a negative. What'd you get? 1. -1. Anybody else on that side get -1? Okay. On this side, are you also getting -1? Yeah, you guys are starting to see you get the same number, actually. So that's not okay. You can't do the log of -1. What even does Desmos say when we do log of -1? What do they tell you? Log -1. Undefined. See that? Desmos is not happy with that. So we can't do that. Even though algebraically we got a number, it's extraneous. So you got this answer, and then we're going to just cross it out and write extraneous, which means that there is no solution. Extraneous. I cannot remember how to spell extraneous. We'll have to look it up. I'm pretty sure it's not that. No solution. I did? Oh, thanks. I had no faith in me. All right, try your 2 problems, please. Okay, so for this one, you could exponentiate by doing raising both sides. So it's 5 to the power log base 5 3x. And then that gives you, is it 3x or 2x? Looks like somebody corrected the problem. It's 3x. So that gives you 3x equals 2x plus 9. And that should solve to be x equals 9. Questions on that one? Okay. And then for number 15, you can rewrite that one as an exponential. 3 to the 0 equals x plus 3. And then you finally get x equals -2. And then look, they checked it. They put it back in the parentheses to see if it works. It looks like they didn't check this one, but it does also work. I can see that. So that means that when I substitute it in the parentheses, I don't get a 0 or negative output there.